So we talked about functions and compositions of functions in section 6.3. Today in section 6.4, we're going to talk about inverse functions. And an inverse function basically just interchanges the x values and the y values. The definition says inputs and outputs, but inputs are x's, outputs are y. So what we're doing is we're swapping the x and the y. Also, your domain and the range are swapped. So if they tell you that the domain of a function is this and the range of the function is this, and you swap them for the inverse. So it's pretty easy. If they're going to give us an equation, and then we have to find the inverse of that function. Okay? So to find an inverse function, you're going to do two things. Your first step is to swap your x and y, and then you're going to solve for y. Swap your x and y, and then you solve for y. This is fairly easy. All right, so to start with, they're going to say, find the inverse of y equals 3x minus 5. Find the inverse function of y equals 3x minus 5. You're going to do those two steps. Swap your x and your y, solve for y. Swap your x and your y, solve for y. So, this is how simple it is, y'all. See how it says y equals 3x minus 5? First thing we're going to do, where they have a y, change it to an x. And where they have an x, change it to a y. So we're going to say, now x equals 3y minus 5. So the very first step is replace your x and y with each other. You swap the x and the y. Simple. So then all we have to do is get the y by itself. So basically we're going to re-put it in slope-intercept form. Does that make sense? We're going to get y by itself. So first I want to move the 5. How do you think I'm going to move the 5? Add the 5 to both sides. So that's going to be x plus 5 equals 3y. And how do you think we're going to get the y by itself? How do I get rid of the 3? Divide by 3, yeah. Divide everything by 3. And then we'll simplify. That x over 3 is the same thing as 1/3 x. Plus 5/3 will not simplify. Oh, that's supposed to be equals y. Or you can rewrite it y equals 1/3 x plus 5/3. So what you do, first thing is you swap places with your x and your y, and then you get your y by itself. So you're putting it in slope-intercept form, essentially. Let's do another one. Find the inverse of y equals 4x plus 2. What is the first thing we do to find an inverse? Only 2 steps. What's the first step? Change the y and the x. So instead of y equals 4x plus 2, we're going to say x equals 4y plus 2. Very good. There's your first step. And what's your second step? What's step number 2? So you want to get y by itself, right? So yeah, subtract 2 on both sides. So that's going to say x minus 2 equals 2 equals 4y. And how do I get rid of the 4 to get the y by itself? Divide everything by 4. And then simplify. X divided by 4 is the same thing as 1/4 x. Minus, what's 2 over 4 reduced to? Y'all got to tell me what 2 over 4 is. Come on. A half. So I'm going to rewrite it just to have a y by itself first. So y equals 1/4 x minus a half. There's the inverse function. Any questions? All right, let's do another one. Example B, here's example C. Okay, this one says f of x equals 2x plus 1/4. F of x is the same thing as what, y'all? Y. It's the same thing as y. So if you see that f of x stuff and you want to rewrite it so you can do the inverse, like when you're doing your homework, if you want to just go ahead and write that as a y in there, that's fine. So now what's the first thing you do to find an inverse? Change your x and your y. So x equals 2y plus 1/4. Now what do you do to get y by itself? Subtract 1/4. So this is x minus 1/4 equals 2y. Now how do I get y by itself? Divide everything by 2. Now that's easy. X over 2 is 1/2 x. But this negative 1/4 divided by 2, y'all know the keep, change, flip stuff? So negative 1/4 divided by 2 over 1, keep, change, flip is negative 1/4 times 1/2. Right? You've done that since 4th grade. And that's negative 1/8. Multiply across. So 1/2 x minus 1/8 equals y. And if you put your y in front, y equals 1/2 x minus 1/8. And there's your inverse. Any questions about those? No. All right, so y'all are going to try 2 of them on your own. And the inverse. This one, remember f of x equals y, so I would change that to y first thing before you swap them. And this one. You don't know if you can or you can't till you try. It's okay if you get fractions. We've been getting them the whole time. All right, when you get them, you can check them with somebody, please. All right, y'all help me out. What's the first thing I need to do on number 1? Well, first I'm going to rewrite it so it says y equals x plus 4 because it's the same thing, right? So after I make it y equals x plus 4, then what do we have to do? Yeah, so then you swap my x and y. So that's going to be x equals y plus 4. And then what did you do to get y by itself? And that's all you had to do, isn't it? So x minus 4 equals y. And if you rewrite it, it's y equals x minus 4. Raise your hand if you got y equals 1x minus 4. Any questions about that one? All right, so on number 2, the first thing I'm going to do is change that to say y equals 2x minus 1. And then what did you have to do? What did you do now? What's step 1? You swapped your x and y. So x equals 2y minus 1. Now how do I get rid of everything with the y? Y'all, I'm asking y'all at junior high questions here. How do I get the y by itself? Thank you. So x plus 1 equals 2y. And then how do I get the y by itself now? Divide everything by 2, and then you simplify. And that's 1/2 x plus 1/2 equals y. And I'm going to rearrange it so it's in slope-intercept form. Y equals 1/2 x plus 1/2. Raise your hand if you got that one. Any questions about how to make an inverse function? So the next thing we'll have to do is verify that two functions are inverses. Verify that functions are inverses. My handwriting is so sloppy today. So the way we verify is you have to prove it. Y'all remember in geometry where you had to prove something was true, you couldn't just take it? Okay, well, algebraic proofs are a little bit easier. All you have to do is work it out and get it to come out to what it's supposed to equal. And to verify that two inverses are true, we're going to use compositions. Now, we did compositions on Friday. That's when we did like f of g of x and g of f of x. Remember that? So what you do is you do a composition. And if you do a composition, if I have f to the negative 1 power, that means the inverse of x. Okay? So that means inverse of x. So I'm going to write that down for you. Or inverse of x, I should say. So anytime you say f to the negative 1 power, that means the inverse of f of x. So if, yes, that's what I said. So if you take f of f inverse of x, it should equal x. And likewise, the inverse of f of x should also equal x. So if you take two functions and compose them and do function composition and you get equal to x, then it's true that one is the inverse of the other. They are inverses if you do composition and it equals x. If it does not equal x, they are not inverses. All right, so this example, what letter are we on? D. So for example D, we're going to do some of Friday's lessons. They tell me f of x equals 3x minus 5. And the inverse of x, or the inverse of f, is 1/3 x plus 5/3. So the way I verify that these two are actually inverses of each other is I compose one into the other, and if it equals x, then yes, they are inverses of each other. So I'm going to take f of f inverse. Do it red. So remember when we do function composition, we work our way from the inside out, right? We take the one on the inside and put it in the one on the outside, in for the x value. So here's the inverse of x. Inverse of f of x is 1/3 x plus 5/3. I'm going to substitute those in for the x right here. Okay? So where they have an x, I'm going to put 1/3 x plus 5/3. So I'm going to have 3 parentheses. And then in for x, I'm going to substitute 1/3 x plus 5/3. And then I'm going to write the minus 5. So all the stuff in parentheses is where x was. Now I'm going to simplify this. If it simplifies to be just x, then yes, they are inverses of each other. You can't just say yes or no. Verify means you have to do the math and prove it. Okay, so these are absolutely requiring work, mathematical work on our paper. That's what verify means. You have to prove that you checked it. Okay, so we're going to simplify this. That means we're going to distribute. We're going to distribute. Y'all, what's 3 times 1/3? Y'all, this is easy. What's 3 times 1/3? Well, multiplying times 1/3 is the same thing as dividing by 3. Multiplying times 1/3 is the same thing as dividing by 3. What's 3 divided by 3? What's 3 divided by 3? Thank you. And 1 times x is x, is it not? So 3 times 1/3 x is x. Y'all get that? Y'all, what's 3 times 5/3? 3/1 times 5/3, cancel, cancel, equals 5. Y'all, I'm asking you elementary questions. Y'all can participate. So that is x plus 5 minus 5. Now what is plus 5 minus 5? Say it. 0. So those cancel and I'm left with what? X plus 0 equals x. Did I get it to equal x? Verified. Those are inverses of each other. So if everything cancels out, you're left with x, then yes, they're inverses of each other. Okay? So if you just put a big check mark, I'm good. But you got to show me the work. Okay? This time they didn't call it f and f inverse. They have called it f and g. So they're saying f of x equals 4x plus 2. G of x equals 1/4 x minus 1/2. And I want to prove that they're inverses of each other. So I can do f of g of x. And if f of g of x comes out to be just x, then they are. So to do f of g of x, I can say 4 parentheses 1/4 x minus 1/2 plus 2. Now, y'all, I need some participation. If you use your calculator, I don't care. Okay? We're going to distribute. What is 4 times 1/4? You really don't need your calculator for that. Yes, 1x, right? What is 4 times negative 1/2? Negative 2. And then bring down your plus 2. What does negative 2 plus 2 make? So that equals what? X. So are those inverses of each other? Yes. You guys get to try this one. F of x equals negative 3x plus 1. G of x equals negative 1/3 x plus 1/3. I want y'all to prove that those are inverses of each other. Prove they're inverses of each other. Compose one into the other one. I would do f of g of x. How do y'all set this up? Okay. And then you distribute. What's negative 3 times 1/3 x? What is a negative 3 times 1/3? Ah. That's supposed to be a negative 1/3, isn't it? Right. I didn't copy right. So that's a positive x. And then what happens with my 1? And do we get it to equal x? We good? So raise your hand if y'all got it to verify an equal x. If you didn't show me it equal an x mathematically, then you didn't do it. Okay? So you got to show it. All right. The last thing we're going to do is really, really, really easy. Do y'all remember when you were asked if something was a function or not and you looked at the vertical line test? Y'all remember that? And if a graph passes a vertical line test, then it's a function. Oh, yeah. If it flunked the vertical line test, that means anywhere I drop a vertical line, if I touch that vertical line in 2 places or more, then it's not a function, right? So what they're going to do now is they're going to give you the equation of a function, and they're going to say, is the inverse a function? So not is this a function, but is the inverse of this graph a function? So guess what? Instead of using the vertical line test, since we're doing inverses, we're going to use the horizontal line test. So use the horizontal line test to determine whether inverses are functions. So we're going to graph a function, and if it passes the horizontal line test, then the inverse is a function. If it fails the horizontal line test, then the inverse is not a function. So I'm going to sketch a few graphs to start with. I'm going to highlight all this. This is important. You might want to highlight it. So we're on example F. I'm going to sketch a graph, and I'm just going to do it free-handed. It's not going to be perfect. Can y'all see that blue squiggle line? There's my function. And it's asking me, is the inverse of a function? Is the inverse a function? So is this one a function? This one's a function if it passes the vertical line test, right? The actual graph is a function if it passes the vertical line test. But for the inverse to be a function, it also has to pass a horizontal line test. That means anywhere I draw a horizontal line, I can only touch that blue curve one time. Am I always just going to be touching that blue curve one time with the horizontal line? Or are you touching it twice at? Well, for this line, I'm only touching the blue line once. This 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 line once. Am I ever touching a horizontal line twice? No. So this one, the inverse is a function. So you would say yes. All right, but what if you have a graph like this? And y'all tell me what the name of this is called. What's that called? A parabola. Is this one going to pass a horizontal line test? No, because if I draw my horizontal line right there, how many times am I touching it? Right here and right here. So is the inverse of this parabola a function? No, not a function. If I can spell function, that would be important.
Oh, yeah.
Yeah. Okay. So if it passes the horizontal, the inverse is a function. If it fails horizontal, the inverse is not a function. So let's use our calculators to do a few. F of x equals 2x to the third power plus 1. So turn on your calculators. Let me get mine turned on. Go to y equals and clear it out. You don't want plots turned on. You don't want anything going on. You want it to look all nice and blank like mine is. Okay? And then you're going to type in 2. Remember the X is right there by the green alpha button. Rooftop 3 to raise it to the third power. And then plus 1. You in here? We're participating in here. This is easy. This is everybody makes 100 on this because it's easy. Now hit graph, which is right here, the right hand side. And there's what our little line looks like. Y'all did do that? Do X-ray. Your plot zone. I told you can't have plot zone. Hang on. Thank you. Okay, because you got something popping in now, way down below. Yep, you do. Somebody. Anyone else not have my graph? Everybody looks good? You got plot on. You got plot on. Plot on. All right. So, and I see there's a little dip right there. Do y'all see that? But it's just because there's not very many good pixels on our graph screen. This is old technology. So, but y'all think I passed or failed the horizontal test? We passed it, right? There's really nowhere other than this little dippy thing right here that I'm touching a horizontal line twice. Right? Okay. So is the inverse of this function a function or not a function? It is a function. So I'm going to say yes. All right, let's do another one. G of x equals 2x to the fourth power plus 1. So all you have to do in your y equals is where it's raised to the third power, you can arrow over, go to y equals, and where it says the third power, since the only thing that changed was the exponent, just go where the 3 is and type over it with a 4. Y'all see that? And then hit graph. And let me know if your graph don't look like mine. It's similar to a parabola. Does everybody's look like mine? So what do you think about this one in the horizontal line test? Yeah, the inverse will not. This is a function because it passes the vertical line test, but the inverse will not be a function. Does that make sense? Because it fails the vertical line test. Because fails the horizontal line test. Because if I draw a horizontal line anywhere across there, I'm touching it twice. Are we good? Well, this one's inverse is not a function. Let's do one more. X to the 6th power. So we're actually going to clear everything out with our y equals. And just hit X, rooftop, 6th power. And then hit graph. What do you think? It's also parabolic looking, isn't it? So I'm going to be touching it twice every time I draw a horizontal line above that 0. So it will also, the inverse will be not a function. Y'all think y'all can do that on your own homework? We think we can do some homework real quick and turn it in and make 100? And let me take this one for a grade and not Fridays for a grade. Does that work for everybody? Okay. So that's the end of the lesson.